Lesson 2.4 is on representing rational numbers on the coordinate plane. So if you look on page 86, first of all, a coordinate plane is a grid that contains two number lines that intersect. So if you can imagine a number line and then another number line meeting it at a right angle. So one's going horizontally and one's going vertically. The two number lines, one we call the x-axis and the other one we call the y-axis. They divide this plane into four quadrants. So if you look at the picture here, you can see, first of all, the x-axis goes across. So here's the x-axis. The y-axis goes up and down. And then the point where the x-axis and y-axis intersect each other, where they meet, that point is called the origin. A way to help you remember the x-axis and the y-axis, the x-axis, if you take the letter x for x-axis, and if you kind of rotate that, take an x and kind of rotate it, it kind of looks like a cross. And so the x-axis goes across. The y-axis goes up and down. So one way to help you remember that is when you nod your head to say yes, then that goes up and down. So just like yes starts with the letter y, y-axis goes up and down. When we go to graph points, first of all, these four sections are called quadrants. So the top right section is called quadrant 1. Usually they use Roman numerals for these. And then top left is quadrant 2. And then below that is quadrant 3. And then the bottom right is quadrant 4. When we're going to graph a point, they will use what's called an ordered pair. So we know where the point's going to be located. So the ordered pair, we put in parentheses, we put an x, and then a comma, and then a y. And again, that's in parentheses. Anytime we go to graph at a point, we can start at the origin. And the origin, we talked about, it's where the x and the y meet. The coordinates for the origin would be 0, 0. It's at 0 on the x-axis, and it's at 0 on the y-axis. So that's kind of our starting point. And then we will use the x-coordinate to figure out how far left or right we need to go on that number line on the x-axis. And then we'll look at the y-coordinate to see how much we need to go up or down from that point. So you can see some examples here. So if you look at the point Q, Q is at the point 2, -3. So starting at the origin, the x-coordinate is 2, so they went over to 2 on the x-axis, and then they went down to -3 on the y-axis. Same idea, r is -1, 1. So first on the x-axis, they went to -1, and then they went up to 1 on the y-axis, and so that it'd be -1, 1. Okay, a big thing to make sure you remember is that you do the x first and then the y. A way to help you remember that is that the numbers are in alphabetical order. We do the x and then the y. X comes before y alphabetically. Finally, if we look at our last point, S is at 0, 2. 0, 2, we start at the origin. The x value is 0. So we're actually just staying at 0. We don't move left or right at all. And then the y value is 2, so we're going to go up 2. So there would be our point 0, 2. So if you look at the try it, they want us to graph the point -2, -3 on the coordinate plane. So to start with, we're going to start at the origin. So they want us to write the coordinates of the origin. we talked about a minute ago. That would be 0, 0. And then when you go to graph these, it's not a bad idea just to write X and Y above the numbers, so that helps you remember which one is which. Obviously, if we do it in the wrong order, we're going to be at the wrong point on the graph. So the X coordinate is negative. It's -2, so we're going to move 2 units to the left. And then the Y coordinate is negative, so we're going to move, it's -3, we're going to move 3 units down. So again, our point we are graphing is -2, -3. So we start at the origin, we go to -2, so 2 points to the left, 2 units to the left, and then we go down 3 units, and that would be our point. So -2, -3. We put a dot there, and then we can put the point P next to it. We can put the coordinates there as well. If we're graphing a bunch of points, it might be just too much going if we put the letter and put the coordinates, but you for sure want to put the letter, in this case the letter P, for that point that we're graphing. Example 2, a grid map of Washington, D.C. is shown at the right. What are the coordinates of the location of the Jefferson Memorial? So the Jefferson Memorial we can see down at the bottom here. One thing we need to look at before we get going with this, though, is that this time the number line is not going by ones. So we need to figure out what decimal or what fraction part each grid line represents. So if you look here, between 0 and 1, there's 4 boxes between 0 and 1. So that means it's split up into fourths. Okay, so it's 1/4, or the decimal would be actually 25/100ths. I kind of like dealing with it as fourths instead of as decimals, but that's up to you. So the Jefferson Memorial, if we start at 0, 0 to get to the Jefferson Memorial, remember we're going to do our X first, so we're going to go either left or right, and you can see we'd have to go to the right 2 places. Remember, each one of these is 1/4, so that'd be 1/4, 2/4, and then 2/4 is the same as 1/2, and then we're going to go down, so this is going to be negative. So -1/4, -2/4, -3/4, -4/4 is the same as -1, -1 and 1/4, -1 and 2/4, -1 and 3/4. So out of that, that's how they got this. The coordinates here is 1/2, -1 and 3/4. And again, if you had decimals instead, you could say 5/10 and -1 and 75/100ths would be okay also. The try it, they're doing the other way around. They're giving us the coordinates and they're asking what's there. So what landmark is located at 2 1/4? So 2 1/4. The 2, we can actually go and see the number 2, so I can just go straight to that, starting at the origin, go to 2, and then go to 1/4 on the y-axis, and you can see that would be the FBI building. Okay, so again, when you go to look at these graphs, just make sure you take note whether they're going by ones, or potentially if they're going by some kind of a fraction or decimal. Example 3, how are points N, -3, -2, P, 3, -2, and Q, -3, -2 related to the point M, 3, 2? So they're asking how they're related to point M. So I'm going to circle point M. And going from M to N, you can see M to N. They're at the same height as each other, so basically their y value is the same. We could talk about, but their x value is different. And one thing we can talk about with this, what the book mentions here, we'll get into it more later. N and M are actually reflections across the y-axis. So in other words, they're the same distance from the y-axis, but on opposite sides is a reflection. Okay, kind of like you look in a mirror and see a reflection. Okay. And then point P, we got a similar idea here with this one. That would be at, that was at 3, -2. So on this, you'll notice these, the x coordinates are the same. The y coordinates are different. So they're both from the origin 3 units to the right. It's just for point M, we went up 2. For point P, we went down 2. So that's where the book says those are reflections across the x-axis. So one is 2 units above and one is 2 units below. So that's a reflection across the x-axis. And then Q is sometimes said that it's a reflection across the origin. So, you know, with reflections, one way of putting it also is that if we look at the line that we've got, a reflection, basically if you folded on that line, the other point would match up, the 2 points would match up with each other. So if you look at the origin, and kind of what they would do here is they could draw a line this direction. Across that line, those 2 points would match up with each other. A little clearer to see with, you know, point N and M and with point P and M, how that works, where we could fold it. And the book just says they're reflections across both axes. Axes is the plural of axis. So if you have one, it's called an axis. And if you have two or more than one, it's called axes. Okay, it's not axes like you going to chop wood, but axes. So here the book mentions again about a reflection is a mirror image across the line. So if you look at the try it, coordinates of point A are -3, 5. What are the coordinates of point B, which is a reflection of point A across the x-axis? So -3, 5, we can just graph that here. If you don't have graph paper, you can kind of just sketch out a graph a little bit. So -3, 5, we're starting at the origin. We go to -3 on the x-axis. We go up to 5 on the y-axis. So here we are at -3, 5. And it says what are the coordinates of point B, which is a reflection across the x-axis. So remember the x-axis goes across. So this is our x-axis. So basically, if we folded on the x-axis, we want these points to match up with each other. So kind of what we're doing is looking at how far A is away from the x-axis. So it's 5 units above the x-axis. So our reflection is going to be 5 units below the x-axis. So that would be point B, and so the coordinates of that would be the x-coordinate's still the same, so that's at -3, but then the y-coordinate is going to be the opposite. So -3, -5 would be the coordinates of point B. So the key concept just kind of recaps things here. Again, coordinate plane is a grid that contains number lines that intersect at right angles, divided into 4 quadrants. Horizontal number line is the x-axis, vertical number line is the y-axis, and ordered pair, make sure you know this part, ordered pair is when we list the coordinates. Okay, sometimes it's called the coordinates, and sometimes they call it an ordered pair. Is x comma y in parentheses. And then you can see an example here. And then also what the 4 quadrants are again. So if you look at the do you understand number 2, what is the y coordinate of any point that lies on the x-axis? So any point on the x-axis, so we could just sketch something out here and think about, so like this point's on the x-axis, this point's on the x-axis, we could come over here if we want, that point's on the x-axis. Let's look at the coordinates of these points. So this one just to the right of the origin, that would be the point 1, 0. This other one is 3, 0. This one over here is -3, 0. Okay, and so the question was, what is the y coordinate of any point that lies on the x-axis? And you can see the y coordinates of all these points are 0. If you look at number 4, on a larger map, the coordinates for the location of another Washington, D.C. landmark are 8, -10. In which quadrant of the map is this landmark located? So 8, -10. Again, even if we didn't have graph paper, we could kind of sketch this out. So 8 is our x, -10 is our y. So we're going to start at the origin. We're going to go over 1, 2, 3, 4, 5, 6, 7, 8. And then from there, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we would be somewhere around here. And so there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4 in Roman numerals looks like IV. Okay, V is 5, I is 1. So this, when you put a smaller in front of a bigger, it means take away. So this means 5 take away 1, which is 4, quadrant 4. If we look at the do you know how, they want us to graph and label these points on the coordinate plane. So for number 5, they want us to graph A, which is at -4, 1. So we're going to start at the origin. We're going to go on the x-axis over to -4, and then we're going to go up 1. So there would be point A. B is at 4, 3, so we're going to go over to 4. On the x-axis, we're going to go up 3, and that is point B. And then C is at 0, -2. So 0, we don't go left to right at all. We're just going to go down 2 units. And so that would be point C. Number 8, they're asking what ordered pair gives the coordinates of point P. So for that one, we start at the origin. To get to P, we are going to go 3 units to the right and 2 units down. So 3 to the right and 2 down. So we go to 3 and then -2 because we went down 2 units. 3 on the x-axis and then down 2. Number 37, they want us to graph and label these points on the coordinate plane at the right. So I've just rewritten the coordinates so I can see them better here. One thing, they were nice, they went ahead and drew out this coordinate plane for us, and they've got them going by fourths. So that makes our job a little easier for graphing these instead of just starting from scratch. So We're going to go to 3/4 for point A. We're going to go to 3/4, and then we're going to go to -1.5 on the y. So 3/4, so we got 1/4, 2/4, 3/4. If you want to, for -1.5, you can go to -1, and then you can say -1.25. -1 2/4 is equivalent to -1.5. So 3/4 -1.5 would be here as point A. B is at -2.75, -2.25. So we can start by going to -2, -2.25, -2.5, -2.75, right on the edge, and then we can go -2, -2.25. So if you want to do the part to the left of the decimal, you can get to that point and then just finish off by going to the decimal part. And then 0, 2 1/4 for C, so we start at 0, we go up 2 plus another fourth, that would be point C. And then D, we're at -1.75, so -1, -1.25, -1.5, -1.75, and up to 2 would put us right there. So that would be point D. So this gives you an idea of how to represent rational numbers on the coordinate plane.